In our code, we can superimpose the output map of the terrain classification model to calculate the traveling salesman problem representation, considering that the edge costs are determined by the specific subsegments of the road or edges that the route passes through. These subsegments have different weight based on the ease of access or suitability for various terrain types, such as sandy, grassy, marshy, and rocky. Here's a more detailed explanation. Terrain classification. Our code classifies different terrain types within an image using a convolutional neural network, the CNN. This provides us with a labeled map of the terrain distribution in the image. Overlay with road map. We overlay the terrain levels onto a road map. This overlay helps us associate terrain information with geographical road segments. Road network segmentation. The road network is segmented into individual road segments or edges. Each road segment corresponds to a part of the road network that can be traversed. Edge cost based on terrain. Instead of assigning fixed edge costs, we dynamically calculate the edge costs based on the specific subsegments of the road that the edge passes through. These subsegments are labeled with terrain types. Example: sandy, grassy, marshy, rocky. The edge costs are determined by the suitability of each terrain type for travel. Now the TSP solution. With the network segmented and the edge costs determined by the terrain types encountered, we can solve the TSP to find the optimal route. The TSP algorithm considers both the geographical layout of the road network and the varying terrain conditions to minimize the overall cost or distance. Visualization. Finally, we visualize the optimized TSP path on the map. This path represents the most efficient route that accounts for different terrain types and their associated travel difficulties. By incorporating terrain-specific edge costs into a TSP representation, we can plan routes that are not only based on geographical distances but also consider the suitability of different terrain types, making it particularly useful for applications like route optimization in diverse environments.
So this is my model that we are building. So here we are using the TensorFlow. We are using the libraries like TensorFlow, NumPy, and Matplotlib. Then we are using. Then you are giving the dataset path. Then the parameters of the model. That is, the classes will be three. The input shape will be like 224 cross 224, and then we are data augmenting, and we are loading and pre-processing the training data. Then we are creating a CNN model using the sequential function. Here we are using ReLU, and we are compiling the model, then training the model, and then saving the trained model, and then we are plotting the train history using Matplotlib. So output is like this. That is, we are having two graphs. One is for the loss, and we are seeing there's a loss, there's a periodic loss to this, and here is accuracy, there's a periodic gain to this. So this is my model that we are doing, or a part of the model that we are doing. Thank you.
After receiving the email and password from the user via as requested, the backend first checks whether the email exists or not. If it does not exist, an error is displayed for the sign-up process. After verifying the email's existence, it proceeds to check if the provided password matches the user's stored password. If there is a match, it returns a status code of 200 along with a success message indicating that the sign-in was successful. Additionally, it generates a token that remains valid for 1 hour, meaning the user won't need to sign in again during this time period. All the relevant user details are stored in this token. Uh, this is the way to upload a map, for which we first need to log into the app since the API endpoint is protected. So after authentication, the user can upload the file, which is then sent back to the backend. The backend receives the file as a string and stores it in the authenticated user's database. This database will be used to display all previously uploaded maps in the user's profile. And this is where we see the map. uh, okay, and following which we also have that after for the profile, when a user hits the API, it first checks if the request is authenticate or not using middlewares are implemented to protect unprotected routes, meaning that only authenticated users can access those routes. After authentication via middlewares, the API endpoint retrieves the specific user's details. It then searches for that particular specific user's details. It then searches for that particular user in the MongoDB database and returns all the user's details, which the frontend will map and display as required.